Hi, everyone. Welcome to the DeSci episode of Into the Dataverse. We're talking to our friends from DeSci Labs, and I'm going to let them introduce themselves. So let's get started.
Hi, John. I, of course, work with DeSci Labs. I also work with a couple other projects in the space, Bitcoin being one since 2013. SciOS, the Science Collaborative Infrastructure and Operating Systems Collaborative. I work with Ellie on that, where we do workshops to unite researchers and technology. I'm also a program manager at NumFocus, which is a nonprofit fiscal sponsor for a lot of the open source Python data science stack. So open source projects like NumPy, SciPy, Scikit-learn, things like that. We help that community and shepherd along. Excited to talk about DeSci.
Yeah, same.
I'm Ellie. I work with DeSci Labs and generally kind of just working a lot on workshops and events. I also work a little bit with the DeSci Summit and then MetaGov, which focuses on governance and how we actually do the work of distributing governance and power among communities. So this is all within the same stream for me, and excited to talk about that in DeSci as well.
Yeah, awesome. Okay, so maybe we should just take a step back for people who don't know. Maybe could one of you explain what is DeSci exactly, or what is your interpretation of DeSci?
Ellie.
Okay, we're passing. My interpretation of DeSci is mainly just there are a lot of really gnarled and entrenched institutions in the way that science works, which kind of limits how much we can do and how well we can actually present science. So DeSci is just, hey, there's a lot of technology that can support our mission towards a more open, accessible science, which is very like open science has been here for a very long time, forever. And DeSci is just like the technology stack that you have or that we have right now is not currently functioning for advancing that mission. So we need something that actually allows the researchers to have the tools they need. And I don't know if John, you want to add to that.
No, it's the technical implementation of open science. I think that's well said.
Those are some good answers. Yeah. So I feel maybe like what we currently have for science and research is not necessarily like the way that it was supposed to be. And maybe DeSci is taking us back to that, or is it or taking us
Yeah,
forward? But yeah,
yeah. Is it back or forward? Good question.
I don't know. I was just thinking
The-
about that because I was
no,
like
no,
like the capitalism of it all. Like, I mean, I'll maybe we'll cut this. I don't know. It's for work, but like it was. I feel like the scientific method and has been around for a long time before we started putting like all of these price tags on everything.
yeah,
Maybe
it was
DeSci is an opportunity.
to get the money out of. Well, you can't really get the money out of it, but you
Well,
can
yeah, yeah.
give
You can't
power
get the money
to
out of
the.
it.
You can give power back to the people who started the scientific process in the first place, which were curious individuals who, at the time, happened to have money for the most part. But ignoring that part, curious individuals who developed a process and used the process to explore the world and built societies of specialization and used those societies to peer review one another, to validate work and to share knowledge that they've discovered. That's what it used to be. And now it's become captured, like Ellie was saying, by a bunch of people who might not be that person who's curious about the world trying to explore it. They might be more focused on building an institution of power or capturing money and raising money and making profit. So what DeSci gives us the potential to do is to give power back to those scientific societies, those groups of researchers who just want to explore particles. Like, hey, you should be in charge of your journals, not maybe three or four industry players.
Yeah. Maybe so I guess circling back to the journal stuff, do you think that there's a way to get people to start publishing in more like decentralized? I don't know if you even would they be journals or whatever they would be, but like publishing research outside of the main like prestige journals like Nature and whatever else people publish in. That's the only one that came to mind. But yeah, how do you get people to see that there's an alternative way outside of the mainstream sort of way when it like maybe it involves like their career progression being dependent on it? And yeah, I'll probably edit this later so that this question comes at the end, but I was just thinking of it.
Yeah. I think, I mean, where I always start with this particular issue is people already are like, I think especially in like a lot of South America, in a lot of non-Western countries, people are quite familiar with distributed scientific societies. They've got sets of peer review. There's high quality science is happening in this distributed way in many places. And there's systems for doing that as well. So like the open journal system services most of it's a open source journal platform that all sorts of people use across the world. I think oddly they have a wild amount of journals in Indonesia. I'm not sure how that happened or why that happened. Like this process is already there. I think the conversation about like advancement and how to work on your career, that's very critical. And this is a question that feels harder, especially in Western countries, but also in bringing up the connection of like, hey, how do we actually elevate and use the research that's happening across the world, not just ones that are published in these big journals? And that's where I have like, it's definitely harder because in entrenched systems, they reinforce their own power. I don't know. So I don't know where that's going, except for that, like, there's plenty of people who are doing it. And kind of going back to that group, I think there's a lot of people right now who are recognizing, oh, this kind of sucks. Like the rat race of pushing into a single journal where we have to pay to publish and pay to access. And like, it just doesn't make sense. And so people are starting to orient around open science in a way that I think is leading towards an ethic of doing that in terms of maybe the technology is something that you would add, John, or some other things.
I think that's a really good perspective. I will add stuff, but I do think that's the core perspective, is that it's similar to a core tenet of crypto, like probably developed in an industrialized country, but we are going to be the last ones to actually adopt it. It's built for people who don't have access to our system. That's the same thing for DeSci. It will be adopted outside of Western countries first, but anything we can do to accelerate the adoption inside these massive powerhouses of scientific discovery would be of benefit. And one of the things that we can do is manipulate the incentives and the career path benefits. Yeah, but also like one of the core infrastructures that actually we're building at DeSci Labs, but core infrastructure necessary to a new open science world is a repository of knowledge that anyone can publish to and access for free. And when you have that, you can put knowledge that's already published, you can put research on that repository just by scraping it. And we just did this with 50 million articles on the DeSci Labs repository. And because we have all those articles now in one place, all this research in one place, we're going to work on getting data sets and code and everything over there as well. You can start doing some interesting novelty scoring. You can start doing interesting things that you traditionally couldn't do in the legacy system. The big industry players could do it because they have the data, but they don't necessarily share that with everyone. But now that everything's in one open repository, essentially a blockchain, but it's not really a blockchain. It uses ceramic, and I think we're very interested in what Orbis is building. But you can get novelty scores. And once people have that novelty score, or they see how their research stacks up to other research in their field and who they might want to collaborate with and what other data sets they might want to bring into their own research, they might, they'll weigh that against the career path of published in Nature. And we might be able to sway them to start using some more novel stuff. In the same way that, when preprint servers came out, people, weighed the options and was like, we're going to publish to a preprint server and also go to Nature. So it might not be one or the other as well. It might be, hey, we're going to publish with DeSci Labs and then also submit to Nature. And maybe Nature eventually uses the DeSci Labs repository to sort of build their journal on top of it as a curation mechanism. It's a great question, and there's a lot to it.
Yeah, that's interesting. I didn't think about that. Are there like, what's it called? Are there restrictions on if you publish in specific journals, like mainstream journals like Nature, on whether you can publish outside of it or like self-publish it or
just the opposite, actually. So there were restrictions, right? When it first came out, don't do this, don't do this. And then people are like, we're going to do it. And so the restrictions dropped. And now there's a funder, I forget which one, and it's silly of me to forget because they're a really big one, but they just said you have to publish all of your research on a preprint server. As soon as it's done, you can't hold it until it gets published in Nature. Like preprint servers are becoming the new mainstream. and publishers are going to have to deal with that. And DeSci infrastructure is essentially just a different technical implementation of a preprint server that enables more features on top of it.
Yeah. What are like the differences then between like a preprint server and what you're building in DeSci?
The thing about DeSci that's really nice is that it's at a slightly higher level of abstraction. So a preprint server, most of the ones that they have, you put on your PDF. And then maybe you've got a link to Zenodo, which will have your data, but maybe only 50 gigabytes of it, which is enough for some people and not for others. And you probably won't have your code at all unless you're extra special and you put a GitHub repo. But it's still a link. It's still very disparate and not connected. So the thing that DeSci Labs is doing, like one of the things that is most user facing, I guess, is all right, my code right next to my data, right next to my paper, right next to my presentation, right next to my Twitter thread explaining it. All of this comes in one package. And it's all identified by a CID or a content identifier, which makes it more persistent than a DOI. So a DOI, the digital object identifier, is the reference identifier for science. But the way that we maintain this is that there's one company that goes through and it's like, the link broke, let's fix it. The link broke, let's fix it. And it goes in circles. But as you get more and more DOIs or identifiers, it becomes like too expensive to go through and check that database. And what that means is we can only actually reasonably identify PDFs. Because if we identified every data point, if we identified every code book, it would just get too big, too fast, and start being quite expensive and more inconsistent. But with the CIDs, you can have a persistent identifier that just stays because it's like locked in. It exists. And it can be like anyone can decide, I want to store this, so then I store it. And as a result, it can maintain even if a journal might die or something else might happen. And what this allows us to do is you have a single CID that references all of the information that you need for your research. And potentially you have another CID down here that references a single data point. And now the mission, although we're not there yet, is okay, you can compose different data points from different research objects. So it's like your research over there is talking about maybe blood samples in a location that is maybe, so read our conversation last time, we've got a completely different sample. You're doing the same information, same process, but it's a completely different sample over there. You've got a sample over here. Now we can combine these data sets and make them much more powerful. So it's a way to kind of re-aggregate, redevelop, reconnect all of the different data sets that exist by making them actually usable, like actually functionally usable, which right now data sets pretty much aren't. If they're open, which is wild and crazy, then it's a lot of work to connect them and bring them all together. But that's the thing that I'm most excited about with labs.
I remember two little stories to sort of reinforce that. Leonie's another partner at Labs, had the enviable task of building a spreadsheet of PDFs, links to their data, and links to their code. And it was an absolute nightmare. You couldn't, like, we found a couple, but most research does not have accessible data and code. But because you have to put your PDFs on a preprint server, you have to put your code on Zenodo, you have to put your code on GitHub and your data set on Zenodo. And then you have to hope that none of those links break. And it's crazy. And then I'm going through this right now. I'm focused on building a project called the Map of Open Source Science, which is essentially a giant data set and a bunch of scripts to help collect and build that data set. And we're going to write a paper about it. And we were just having this conversation in the working group of like, all right, we're going to write a paper. Where are we going to publish it? All right, then where are we going to put the code? Okay, then where are we going to put the data? And it's like, that should not be, it's a pretty long conversation. It should be, we're just going to publish it and put everything in one spot. And when you have everything in that one spot, you empower more than just the data set. It's the code as well. We'll be able to cite open source code that's used in research and sort of, I don't know, elevate it to the stature that it needs. We'll be able to modularize the research process. So if you're a really good developer, you can produce code that's used by researchers so that the researcher doesn't need to use part of their grant to produce really bad code that works for their one specific use case, which is what happens right. And then if you're really good at collecting and analyzing and sorting and cleaning data, you can go do that data work and not have to be a critical thinking researcher who then decides how to analyze it. And that brings in so many more people into the scientific process, unlocks a couple billions of minds to contribute to knowledge discovery, which is ultimately what humans, I like to think, do in this world. It's discover the world.
I think we might need a reminder sometimes of that. But yeah, I mean, that sounds pretty ideal, even on like it would just create more jobs too. But there's definitely like a lot of issues with data collection and that I think, yeah, we just need really really good infrastructure for data intensive applications to be able to process this at scale and, in a way that's more like financially feasible. Yeah. So you kind of already talked about like interoperability and I don't know if you want to expand on like, how do you see like interoperability? I guess you were talking more less about interoperability, more about like other thing, but like modularity and stuff. But how do you see interoperability in DeSci? Like, how do you think it's crucial for building like more successful decentralized tools and systems? And yeah, what do you think is
I struggle with the interoperability question because, for my mind, it's you have a repository of all the knowledge. Why do you need to
yeah,
have and you can just access it? You have the data and the code.
right. Yeah,
What
yeah.
are we interoperating on?
Yeah, that's true. Like
And maybe
this is Ellie's fault. I'm blaming Ellie for this question because Ellie brought up interoperability in our last conversation.
I
And
think I'm much more
yeah.
into interoperability.
Okay, then Ellie, why don't you answer this question about interoperability?
You answered the question about interoperability. The thing I find important about interoperability is that centralizing a bunch of stuff has always seemed to lead to a single point of failure in the past. And so, yes, single repository, but the thing that interesting or fascinating and something that I've thought about in terms of different structures for hosting data in collaboration with lots of different people. But for example, there's a nano publication format, which focuses on a very niche way of connecting a subject, a predicate, an object. So you're just like, this thing relates to this other thing over here. It's very niche, hyper specific, and works really well for a couple core things. But it's kind of hard. You kind of have to have an ontology. It forces a lot of structure there that doesn't always need to be there. But it can be really helpful for researchers who have specific structured ontologies that they really want to enforce. This is interesting. But if you commit to nano publications right now, you're committed. Like suddenly all of your research has to go into nano publications. Everything has to go there. There's no communication between, for example, DeSci labs and nano publications. There's no communication between your AWS node and nano publications. And what this creates is a reinforcement of we have to have a single design that works for everyone in order to work together well. But that's not that useful because everyone doesn't need a single design. Like I, as a someone who did psychology research in my undergrad, definitely don't want the same data design as someone who's working on fluid dynamics because fluid dynamics data is probably way easier to make open, but way more heavy. Whereas I can't make any of my data open because that's really like it's violating safety rules. And so I need much more privacy. But there are ways to create connections across these, like there really does need to be connections across these different bits of information. Otherwise, we can never unify them. We can never use them in the same context. And as a result, you create the thing that we have now, which is these big cities or silos that don't actually communicate to each other. It's like, I'm psychology. I sit here in a corner. You're fluid dynamics. You sit there in your corner. And then we don't interact. And now finding the overlap between fluid dynamics and psychology is kind of hard. But between cognitive science and psychology, right? There's different tools and different affordances that people need. And I think we should really reinforce the fact that we'll never have a universal thing that works. And that's okay. That's perfect. Because like leaning into design differences that are really hyper specific, as long as we can go up a level and unify them when we need to, is really critical. And so the act of interoperability or making sure that your nano publication inputs or outputs can go into DeSci labs inputs means that now you can use the benefit of labs discoverability. You can use the benefit of the kind of this universal unifying group of information while also having the hyperspecificity that some researchers definitely need. And so I think for me, interoperability is just, it's allowing for the local hyperspecific ontologies that research does need in order to get into the details, but also allows for us to discover and explore and understand the connections between these different things. So this is my pitch for interoperability.
Yeah.
Good
So
pitch.
it makes sense. I look at it from I think it's the same way, just different framing. So the multi-currency economy sort of situation where you have Bitcoin and then it's open source. So it lets everyone experiment with different incentive structures and economic systems and economic networks. At the end of the day, they all do come back. They need to communicate with one another, the different blockchains. So we know where money is, XYZ. And we developed oracles and systems like that to enable that interoperations, I suppose. That I entirely agree with. Yeah. The framing, I think, is layers instead of there's a core settlement layer, which is the repository of knowledge. And then on top of that, people branch off and build their small niche sort of specialties. And as long as they can all come back to that settlement layer, then the information goes back to the settlement layer and goes back up to the other branch, et cetera. Yeah, it is the same idea. We should talk about this more, Ellie. I don't think we've ever had this conversation.
You can duke it out here. Take this in a different direction now because I've been all over the place with these questions. So, that's just how my brain is, but whatever. My question is about the peer review process, which is something that Ellie talked about a lot when I spoke to her last time. But maybe briefly, like, explain what is wrong with the peer review process right now and how DeSci can fix that, whoever wants to.
I did this already.
Oh, okay. It was given a name. Peer review should not be a process. Peer review is just a thing that should happen. This is what it used to be. You publish knowledge and then your peers review it and they're like, hey, you screwed up. You put a 3 instead of a 2. You should probably fix that. And because we gave it a process and we ingrained that process in institutions, it's now like this oracle that we're not even sure works. Like there's so many studies that say peer review does not necessarily make the best research. It depends on which type of peer review you do. There's other ways to make better research and ensure it's correct. And what DeSci, the technology behind it can do is simple things like one-click reproducibility. If your data, code, and manuscript are all there, you can click a button and ensure that the charts in the paper are the charts that the code and the data produce. This modular system that DeSci enables says that, hey, you're going to be able to have peer reviewers who just enjoy being peer reviewers, and they're not PhD candidates that are being forced to peer review. And that's a thing. If you're just doing peer review because you love to peer review, that's wonderful. On top of that, we can build incentive structures for peer review, where you're peer reviewing and you're getting rewarded for it based on 1,000 different ways we can do incentives in Web3. All those things. And then there's the career advancement. You can be a peer reviewer and get career advancement. You can be a peer reviewer from a nation that might not have access to the academic institutions we have. So you don't have an on-ramp into our world of science. And now, because you are a curious person, you can peer review stuff and build reputation, learn, and be recognized for that work and get access to higher degrees of education through that. It again unlocks, this is a core value prop for DeSci. It unlocks billions of minds to enter the scientific process. And this is one of those very simple on-ramps. At the end of the day, though, I don't think peer review is going to be called peer review in 30 years. I hope not. It's so silly.
Yeah, makes sense. Ellie, do you have anything to add?
Not much. I think the core things for me are okay, define what we need to review, make it very clear, export the things that humans don't need to be doing to things that computers can do by making sure that the science that we're submitting is checkable. So instead of just you can't really check a PDF with a computer, just because you can't follow the lines a lot of the time. But if we have the research, if you have the data, if you have a way to evaluate, you at least run. Anyone can now take this and run with it. That's check one. and then going down to like distributing the labor and making it clear, like, hey, you have evaluated this particular item, yes or no. Makes it at least a little bit less. I think the only thing I would add here is like a little bit less like hoity-toity. I don't know if that's the word, but there's this thing going into science. People are like, it's been peer reviewed, so it's valid. And I think there needs to be kind of a shift in that mindset as well. Like, no, we need to be critical, at least right now. Like, peer review isn't doing all of the work it needs to be doing to making sure things are valid. We need to do the work of replication. We need to do the work of actually checking if work is good, not just reading through and being like, seems fine. Which, not to reduce the amount of work that people put into peer reviews, but the complexity of the science is such that what we can do in our typical process of peer review, which is maybe multiple hours even of going through a research paper, is not sufficient to catch the errors that can emerge. So it's just that like we've reached complexity that needs to be redesigned.
I love that it's become an end more than a means. It's become the end itself. So like we forgot what the purpose of peer review was,
Yeah.
just to get peer review. Yeah.
Yeah, that's true. Well, so I guess, do you want to tell us more about what you're doing at labs? Yeah, I think that'd be a good place to go.
In terms of what level of technical or non-technical specificity.
Okay, if you were going to give me an elevator pitch on DeSci, what would it be?
Okay.
It could be a long elevator ride.
Yeah. Okay. Labs is redesigning how we identify research objects, which is important because it ensures that the scientific record can or has the opportunity to be much more stable. It's stable not in the sense of it won't change, but instead stable in the sense that we can track that it's changing. So you have a research object, you're like, oh shoot, I messed up. You try again. And that's visible, it's shown, such that you can see how something emerges and evolves. It gives us the opportunity for everyone to actually collaborate on a research object. I've added this to it. Now I have credit. It is seen that I contributed in a way. And so now many more people can contribute. It also allows for me to always find this research object. This is where ceramic comes in. We use stream IDs. The exciting thing about stream IDs is now we can update research and still have the same stream ID. So you always will return to this set of versions, even when you're changing things. So you don't you get rid of kind of some of the frustrations of a blockchain or a CID, which is, oh, now I've changed the content, it's completely different. I can't ever find it again. It's messed up. And instead, we use this ability to have a very stable, consistent identifier that holds this evolving hub of science. And so it changes, I think, the thing that I'm excited for, and this might be extrapolating. So, John, you can like slap my wrist. That's exciting, or the possibility of DeSci Labs, is that it turns a research object from a static item, like a PDF that you've published and it's done, it's gone, to a constantly evolving piece of research that we can actually check and check again and redefine and iterate on and replicate and make sure that what we're building on is so much more solid than we are right now. Like right now, science, like there are holes in the foundation. Like things are kind of like you keep finding, oh shoot, now that didn't replicate. And the thing I'm basing all of my research off of it's not valid anymore. But instead, we have a way of focusing and contributing and collectively figuring out, hey, is this valid? Now we can make it more solid, and everyone can come in and do that and be credited for it. And it gives a lot more traceability, which gives us the affordance to support people, to credit people, to create more jobs, to have more focus on it, which we don't currently have. It's just, John, what's your elevator pitch?
Yeah. How many floors is that?
That was like
It's a long
that was the
building.
biggest skyscraper, one of the biggest ones.
All of that is dead on though. So what we're building is the PDF of the digitalized process of science. And what that process is, it's modular, is cross disciplines, it's interdisciplinary, it's collaborative, and it elevates researchers to the status that they deserve, and it doesn't relegate them to laborers. Researchers are the core creator class of our society. They produce everything in our world. They're responsible for it, from light bulbs to toothpaste. And so what we need is infrastructure that recognizes that. And that's what DeSci Labs is building. And then everything else said.
Awesome. All right. So that was a shorter building, but both buildings are equally valid and I appreciate both of them. I think, okay, my next question, I guess this should be my last question because it's getting late, but what are there any exciting projects that you've seen in the space that like really capture your interest or yeah, like some infrastructure that's interesting for you or yeah, anything that's getting you jazzed up where you're like, wow, that's incredible.
So the MOS project that I alluded to before, the map of open source science coming out on Funkus, one of the is a giant data set. We're building something called the simply omniscient layer of everything in digital research. One of the core use cases that I would love to see come out of that is the ability to track. I'm deciding which way to go, bottom up. Let's go top down. All right. So let's say we have a product that is sold on the market, produces money. That product is dependent on a patent. That patent is dependent on translational research. That translational research is dependent on foundational research. That foundational research used open source software to produce knowledge, to discover knowledge. That lineage is incredibly interesting. And I want to be able to take some of the money we make from selling toothpaste and trickle it to every participant along that stack down to that open source developer who didn't get paid to produce something they're passionate about. And the technology to enable this, Moss is just a database. It doesn't enable it. It hopefully will be used in that process, but the technology to enable that is starting to come to fruition. And I don't want to share too much about it because I don't know but it's out there and it's very exciting. There's a lot of other stuff that's like novel funding infrastructure, even the stuff that DeSci Labs is doing pales in comparison to that capability of actually taking economic output and driving it down to the entire stack. Yeah. So that is new to me at least, and love it. I can't wait to see it.
Can you share the name or no?
I don't think so because I also don't know what it's called. It's a tech that exists.
Well,
Okay.
it sounds good to me. Ellie, do you want to go?
Yeah, sure. So I thought you were talking about drips, but you're not. But drips
It's
was
not
my
Jeff.
excitement, which is similarly trickling, I think, trickling resources from people who have resources to open source in a way. I think another one that I'm starting to get more into is CurveNote. CurveNote is doing very nice things with the format of research papers. So it's not just shifting like, oh, like now we've published a PDF, but it's allowing you to actually collaborate and interact. One of the like more philosophical ones that I really like is discourse graphs. And it's this really functional way of creating a collective lab mind. Like at the level of a lab, you can collaborate and build up evidences. And I think this would be like a new medium for research where you actually publish your discourse graphs. And then maybe this is where you can use other tools to create the narrative that comes out of it. But the discourse graph is all of the context around who's supported and who's working. And it gives a lot more transparency into that process. Another related one for data management is something that's coming out of block science called the knowledge organization infrastructure. And it focuses on unifying different sources of information. And so that one's really super cool because it gives you the ability to create like a super hyper, similarly to what we were talking about with interoperability, like a very hyper local ontology where you're like, and this is where this is coming from. It's coming from my logseq. It's coming from my Notion. It's coming from my Google Doc. It's coming from all of the different places. And we put a reference identifier, little wrapper over it, and then you can access that information in a single area so that you can actually understand what's going on. You've defined the graph edges between them. And then anyone can you can share that openly so that your repository is more easily interpretable across a global little mycelial network. So I like the connection. I like graph things, I think is the conclusion out of that.
Yeah,
I
I was
didn't
looking
realize
up as
before.
you were talking, and I was just like, "This is a graph. This one's a graph." The one that I wasn't sure about was the last one, but the block science. But yeah, it looks
Also
cool.
graph.
Like,
very graphic.
It's yeah. I had a feeling, but I didn't want to assume. Yeah, I mean, thank you guys so much for everything. That was a really interesting conversation. I felt like I got a lot out of it. I understand a lot more about, yeah, what you guys are working on and what you guys are excited about. That's a really cute dog too.
Isn't
Um,
she? Gosh.
she's so cute. How old is she?
3. How old are you? 3.
She
She
talks.
looks
What if
me
she just
dead in
like
the
she
eye.
just
Yeah.
what would you do if she just responded right now, like she just said it out loud, like and it was caught on this call?
Another day in the life of Coda.
Yeah, dogs are the best, but that's like one thing we can all agree on across the board. But yeah, well, thank you for the cute dog, and thank you for your time and everything. And yeah, I mean, I would love to talk to you guys again, maybe with something more specific. But it is really cool, like overview of what you guys are working on, and I think it's super exciting. I'm still really excited about DeSci in general. So yeah, thanks.
Sweet.
Absolutely.
Thank you.